Hello, welcome. This is Noel Martinez from Code Mentorly. In today's episode, we are going to be discussing Problem 217 from the Blind 75 Leetcode questions. This problem talks about contains duplicate. So let's begin with our T's. The T's are the inputs, the type of the input, the output, the type of the output, and any constraint. In the solution part of this video, I'm going to discuss three types of solutions. I'm going to discuss the solution of brute force, of a semi-optimal solution, and the best optimal solution. So you're going to see three solutions. Now, let's take a closer look to the example one. We have the input parameter of an array. The array is integers, and the array is not in decreasing or increasing order. The output type is a Boolean type. In other words, when taking into account our algorithm, we cannot assume we are going to have an array that is already sorted. And that's one of our first hints and one of our first important pieces of information. Now, in the constraints, we see here that the length of the input array can be equal or more than 1, up to the maximum amount that the integer type allows. So in this case, we can begin our algorithm in pseudocode by noting that if the input array, which is nums, equals 1, then we are going to return false. Because, hey, we need a number that at least appears twice. If the number appears twice, such as 1 in this example, in example number 1, then we return true. In here, we don't have any repeated integer. And in here, in example 3, we have several repeated integers. So, of course, if we have an input array of length 1, that means we have only one item here, so we return false. That's going to be our starting point for our algorithm. So I'm going to start by the brute force approach. Okay. Now, the brute force approach, generally speaking, most of the time tends to be of complexity because of n squared, but that it is not always the case. But in this case, we see that for input array 1, 2, 3, 1, we have to compare the present pointer to each one of the other items. And if the item is equal, then we return true. If we iterate and if we compare every item to every other item in the array and we don't see any item that is equal to its current number or its current index, that means that we return false because we didn't see any. So let's complete by coding our pseudocode algorithm. So we start by for loop of I until nums length minus 1. Okay, and then because we're comparing the current pointer in position I to every other position, we have to name that other position another variable. So we are going to do another for loop with the variable j. Which j starts after, hold on, j is I plus 1 until num's length. Now we have to make the comparison. If nums of I equals nums of j, this is what's called a loop invariant, so we can break the current iteration of both loops and just return true. If we complete the comparison of every single item with the rest of the items in the array and we didn't find another item that is equal to its current nums of I, that means that we complete the routine by returning false. Now, this is the brute force approach that has a big time complexity of big O of n squared, because we have two loops that iterate for every number in the input array. So we have n elements, that means we have two loops, so that's n squared. Okay, now let's do the pseudocode for our semi-optimal solution. For this semi-optimal solution, we have to also take into consideration the constraint that if num's length equals 1, we return. We're gonna return false because we need at least two items. To make a valid comparison. Now, I mentioned at the beginning of this video that we cannot make an assumption that the array comes in a sorted state. So that's gonna be our clever piece of information for this following trick. Again, I mean, it's not a trick really, but it's a piece of information that is going to allow you to have a big time complexity of big O of n log n. So there are different sorting algorithms, but in the case of Java, there's part of the standard library that has an object of arrays and sort the input array. And this has a big time complexity of n log n. So when we type this piece of code in Java, it's going to sort the array in place. That means we don't have to assign this piece of code to another object. We don't have to double our space complexity. So after checking this constraint and sorting the algorithm, now we have this input array. And now we just make one for loop of I until num's length minus I minus 1, sorry. That says, okay, is the present item the same as my previous one? In this case, we cannot make the comparison because this one is the first one in the array, but we can make the comparison of this one with the previous one. When we make a comparison with a previous item, that calls for another variable, so we can hold that variable in a temporary fashion. So I'm going to write here temp prev as temporary previous value. And we're going to initialize this variable as, let's say, yeah, we can initialize it as 0. Okay, so then here we're going to compare if nums of I equals to temprev or temporary previous, that means we return true. Return true. If not, we update the variable with its current num of I. If we complete the iteration and there's no duplicate, we return false. Now, this loop is iterating through n elements of the array, but here, when we sort the array, we have a time complexity of n log n. So that would be like 2n log n. And remember, we don't care about coefficients and peak of time complexity. I mean, we care about it, but doesn't have an impactful, doesn't have a great impact on their algorithm. That means we drop it and we consider this algorithm as big O of n log n complexity. If you're curious about the sorting algorithm that happens under the hood, that happens in the background of these lines of code, is the heap sort. Okay. Now, let's move to our final solution, the best optimal solution. Let's take a closer look. If you're fairly new to programming, sets are an unordered list of items where every item is unique. That's a set. Imagine a magic bag that if you have twins and you put twins in that bag, one twin disappear. I'm sorry if you're a twin, that's my best analogy. So again, we start with the constraint that if nums has a length of 1, we return false. We have a set, let's call it unique set, which is kind of oxymoron because sets contains unique elements. We start our for loop. And we ask if the present number is already in set. That means we can return true because we found a duplicate. If not, we add the item to the set. Remember, sets, when you can add 3 times the number 4 to a set, but when you print the items into this, you're going to see only one item, which is going to be only 1 4. We are not going to have 4 4 4. Sets automatically gets rid of duplicates. So that's why this comparison runs in almost because of constant time. So this whole solution, because we are iterating through n elements, that means this solution has big time complexity of n. Now, let's code our solution in Java. Alright, so we have our set of code in the left side of the screen, and we have Leetcode here on the right side. So let's begin by checking for the base case if the nums length equals 1. Now let's create a set. let's check. We are checking the base case. We are creating our set. We are iterating through the array. We are returning true if the set already contains the current number, and if not, we add the number to the set. And of course, we are not in Python. How do we create a set? And this line is wrong because we have to create a hash set. Alright, let's see. Yay! We got it working. Alrighty. So, thank you for watching. If you like the video, please give me a thumbs up, subscribe, and hit the notification bell. And until next time, and keep on coding.